will stop sharing because Gavin can then start with his very interesting presentation.
So let me share my screen real quick.
Yeah, we can see it.
Yeah.
Perfect.
Hi everyone. Thanks again for having me. And I would set up this short period of time that we have in a way that if you got any questions, feel free to interrupt me. Happy to answer at any point of time. And I also would try to keep a little bit of time in the end so that we can actually go deep into your questions, so that you actually remember some stuff after this. So, really quick about myself. I'm a software engineer too, which means I'm actually coding smart contracts and dApps on the blockchain, and I'm also leading a small team where we build products for the Web3 space. So actually, I'm deep into it. I see what people build, what survives, what dies, and yeah. So today we're gonna talk about the technical side of it. So really quickly, I'm pretty sure you have heard a lot of things already, like why blockchain exists, what this is for, how it works, and I also already heard a lot of more technical terms like staking and so on from your previous presenter. So there's definitely not a lot for us to cover here, but I just want to recap that so that there's really some strong baseline here. And I don't think we have time for the practical part here, but still, um, like if we do or if you have some questions here, also happy to go over it. So I would say really quick blockchain intro again, uh, like for a lot of use cases that we see in Web3, people tend to think blockchain is a great choice for actually building on that infrastructure. So we have seen people building decentralized location services for dogs, like if they get lost or things like that, or decentralized computing for AI and whatever. Right, so there are a lot of things where people think blockchain makes sense, but I'm not here to tell you, okay, that's bullshit or that doesn't make sense and that does. But rather, it's important to ask ourselves why blockchain exists at all. And that gives us a lot of clarity for what things we actually should use blockchain for and what maybe is not the best approach. So, first of all, blockchain itself has been created on one side to remove intermediaries, as you might know, and to avoid the reliance of trust, which means in best case you don't need to trust anyone, you can trust the code, the law on the blockchain. So whenever you see a Web3 use case out there that doesn't rely on that, there's always at least a weaker argument of why blockchain makes sense here. Doesn't mean it's bullshit, right? But it means it's not why the blockchain has been created. So there needs to be some other reasoning of why you would use that over a centralized solution, which is oftentimes cheaper, faster, and easier to scale as well. So, as you know, we have seen a lot of evolution going on in the internet, like the first website ever. Then we got our Web 2 world with social media where you can upload and create things. And now we have Web 3 with data ownership. Right? You, also that's a big promise. You own your data, you are the boss, you decide what happens. That also comes along with a lot of responsibility. If you lose your wallet, if you lose your private key, your seed phrase, these 12 to 24 words, they're gone forever. Right? So that's a big pain point for a lot of people out there that used to have a lot of bitcoins and then are looking for it on the landfill, for example. But let's get a little bit more technical, right? I'm pretty sure I've heard all of that already. So, how does the blockchain in general work under the hood? Since blockchain has been evolving and has been changed from architecture and technical perspective over the years a lot, let's just try to cover the really basic from understanding. At the screen, we have these little hands, like five of them. I'll sure if you can see my mouse pointer here. Uh, each of those, for example, is a transaction, right? Person A sends person B $5 in crypto, which could be in Bitcoin, in Ethereum, in USDT, whatever, right? It's a state change on the blockchain, which means we basically have a huge Excel list where we write these things down. We say person A, like Kevin, sends Lisa X, right? So these things are written down with the exact same, with the exact time, date, value, recipient address, which is basically your account number, and all these things, like everything we need to know. And these transaction details are then combined, like compressed basically, into a block, which is that Lego block, for example. And a block is nothing else than a fancy word for, okay, that's the container, and this container contains, as the name suggests, all my transactions, right? All and other people's transactions. And this block is then sealed, like signed, for example, by a lot of people around the world. This is a final like state after this block, like everything that happens before is now signed on the blockchain, saved there, and everyone in the world sees for public blockchain, for example, that these transactions have been conducted with all the details that we've discussed before. Which means create such a block, right? We have these transactions. We want to make sure nobody can change, tamper them, or manipulate them in some other way. Which means if you change the timestamp, okay, well, I sent it like 1 year ago, but in reality it was like 1 week ago. Or I changed one Bitcoin, but in actually I just sent 0.1 Bitcoin, which of course makes a huge difference. All these things, we want to avoid that. We need to have a single source of truth. And since that, we don't have intermediaries here. We don't have a bank that is actually making sure this information is true. We need a lot of people around the world that actually evaluate and control these blocks, these transactions on the blockchain with, for example, with proof of stake, like they risk a certain amount of money in order to validate this information, or with proof of work, and all these other consensus mechanisms, proof of history for Solana, and so on and so forth. So there are a lot of different mechanics of how this is being done, how you come to the consensus, because you don't have that central party. But in the end, it's really just trying to agree on a single source of truth, like one truth of the blockchain state. And this is usually just cut like after each block, right? And the block, as mentioned again, is just a container for transactions. And yeah, as you can see, we have a lock after each block. And these are usually, for data integrity on technical point of view, like defined through a hash. You can see an example here, like it's basically just an alphanumeric value of a fixed length. And that fixed length contains the information. Right? Which means, like, you could, in theory, or not just in theory, you could compress all the information in the world, like every book in existence, the whole internet, Wikipedia, everything, and still get that, for example, 32 fixed length hash, right? It will always be the same length. So at the same time, you might think, okay, well, how can I get all the information in the world out of that fixed length string? You can't, or you shouldn't be able to, right? So that's a promise here. Like no matter what information we have in that hash, you can't get it out. But, and that's the cool thing here, if we feed the algorithm with the exact same information, we get the same hash out of that. So that makes it tamper proof. So in the end, basically everyone around the world like that is contributing to that consensus mechanism just needs to verify that the hash is the same, right? They need to have the same information, the original and the next state basically, and then they can compute like, is that the correct hash? Did someone tamper with any of the transactions in the block? Is there something that has been manipulated or changed? So if you just change like a teeny tiny detail in one of the transactions, which could be like sending 1 cent less or more, or changing the transaction time 1 second earlier or later, this hash will look completely different. And that's the power, right? So a distributed ledger is actually really just a record keeping of all the transactions and making sure that these transactions have not been tampered with. And this basically works in that way, right, from a high level technical perspective. So we already have talked now about consensus mechanisms a little bit, like proof of stake, proof of history, proof of work, and all these other fancy terms. But what exactly does that mean? There's like one major differentiation I want to make here, like distribution versus decentralization. Like if you, for example, create a backend service, if you create a web service on Google Cloud, AWS, Azure, basically a website or a mobile application that queries some data from some sort of API or whatever, or even ChatGPT, right, is also bound to a backend service. There's not one single server sitting there and working on your request, but instead it's a lot of different services that distribute the load, right? They carry on that heavy load and they work on your request. So what does that mean, or why do we do that? It means if, for example, one server is overloaded, or if one building where the server is located burns down, which you can see on the left side here on the slide, then the service still operates. Just imagine if you're Google, for example, and you just have one server, and for some reason there's an earthquake or whatever, and then Google is down. That would be crazy, right? Because it's one of the most important web services we have today. And so that this actually is very, very unlikely to happen, you distribute the risk and the load across different servers around the world, different geographical locations, different buildings, different service providers, and so on and so forth. That's distribution. That means there's one company controlling all of these servers. Of course, Google controls all their servers because they want to. So, and most likely also have to, right? For their stock investors and so on. So that's distribution. Decentralization. Decentralization provides, in general, very similar or the same benefits as distribution, but with one key difference here, you have different companies or individuals managing these servers, which means that that could be a node or is a node, for example, because in a blockchain environment, you have a lot of people operating the blockchain, or different companies, different actors, individuals. Oftentimes, you don't even know who they are, which is also great for censorship resistance. And that basically creates that decentralized aspect, right? You don't have or shouldn't have one single party that controls that infrastructure. And that's the key difference here, right? No matter if one building burns down, it still operates. That's distribution. But also if one company decide or government decides to censor a server or transactions, the other parties can still compute your transaction and the state change required. It's kind of a voting mechanism. That's why it's called consensus. And that's kind of the key difference here. If you understand that, and like the blocks that we've talked before, you already understand blockchain to a very high degree, right? And you can actually, like, if you look into white papers and all these other crazy terms and things, it's usually just the same thing. Those are the basics, and they're almost always the same. And yeah, as you mentioned, it's basically a consensus that people, the majority of the network needs to come to. And as long as, depending on the consensus mechanism, you, for example, have more than 50% of individuals and companies agree with a blockchain state, you basically have a single source of truth by voting. Right? And proof of stake, proof of work, they're all just different ways of coming to consent. As you might know, we have proof of work, where it's kind of through energy and computation. We also have proof of stake, which is less computational expensive, but you vote with your money. Basically, you put something at stake, right? And then you have to be honest, otherwise someone slashes part of your money and you lose money. If you're honest, on the other hand, you earn money. Right? So that's kind of the game theory. People can try to cheat, but it's not worth it. I think that's kind of the key lesson here. And from my understanding, before we continue here, I think the time is already quite close, right? So I would keep the stage open for some questions if there are any. I hope it was kind of understandable.
Hi. What my question is, when you talk about blockchains, uh, do they put in, like, in each block you say there's a lot of other little blocks in there. Do they put everything in the same block? For example, if this money transaction and real estate purchase, they put everything in one block, and then when that's filled up, then they go to the next block.
I mean, that's a great question, by the way. Um, there's usually something called a block time, right? And every blockchain is different, right? I really want to note that here. There's something like a block time, and you can consider a block like something that happens in time intervals, for example, right? If a block is full, of course, uh, you need to create the next block, but usually, like after a certain period of time, the block can still be empty, right, and still be saved on the blockchain. Just means nothing happened, right, and it's just confirmed. Okay, the state didn't change. So there's a certain amount of information, a certain amount of transactions that can go into a block. So yeah, that's absolutely right. But it's not required to follow.
So if the block is not empty, they still gotta close the block and go to the next block.
Like if it's not empty and if it's empty, it still goes to the next block. Yeah.
Oh, okay.
It's really just okay. What did happen? Or what changed? If something at all. And here is the state change we propose, right? It's kind of that's my, as we think that is what should happen, and then people vote on it and come to consent.
Okay. Can I ask you another question? Okay, about proof of work. So I was studying it. So they say the proof of work is the previous hash, and then the message, and then your nonce, and then you make the hash. So you know the hash, the expected hash has to be less than a certain number. Say the hash, I know it's a long number. Say you minus 10 on that hash, okay? So now it's smaller. So since you already have the previous hash, so you already know, you subtract that number, and then you have your message, which is also a hash. You can subtract that number. You got your nonce, and then you can. So instead of doing all the proof of work, you can just say, here's my nonce, and now if you become a miner, then you don't even have to do any work. And then there's no reason to pay all that money to pay miners to go get the nonce. Do you understand what I'm saying?
Not sure if I understand your question, but the nonce itself basically is just making sure you can't repeat something, right?
Mm-hmm.
It's kind of a protection mechanism. Like when you say a transaction also has a nonce, right? If you make a transaction in your wallet, you start with nonce 0, for example, that's your first transaction ever on that wallet, and you then can't broadcast to the blockchain another transaction with nonce 0. That's kind of the purpose of a nonce,
Mm-hmm.
and like how proof of work, for example, like what's the question? You mean like if proof of work can be hacked or
My question is, why do they have to pay so much for proof of work? Because you can just do all this, you can actually do in one step and then you're done. You don't have to go try, and see if it's less than the target value. You can just make your own target value.
well, first things first, I'm as a consensus specialist are like highly specialized people, right? I'm not one of those. But in general, um, just trying to make sure I don't say something stupid or wrong here. If you, so you definitely, first of all, you can't trick proof of work, right? Like if I
Mhm.
understand your question correctly, um, it's kind of like also here people agree on something, right? If it's, for example, a target value and they say, okay, we want to find out that, and you say, okay, I want to do something else, then you basically are working on a new blockchain, you know? Like if you want to diverge from the source of truth. That's what oftentimes happens when people don't agree with a common state. Ethereum Classic, for example, right? Or when Ethereum also switched to proof of stake from proof of work, the proof of work blockchain still exists. Almost nobody is using it, but it still exists. Right? So you can do whatever you want. It's permissionless, but it might create just a separate blockchain that nobody is using. Right? You can do whatever you want. You can change the state. You can make yourself rich, but the money is worth nothing.
Mhm.
It's kind of just an Excel file. You can write whatever you want in there, but if the network doesn't agree with you, you're not part of the network basically, because you think something else is true. So either you get punished, like in terms of proof of stake, you get slashed, or you basically create a separate blockchain by thinking that that's my source of truth. Right? And if other people agree with you, cool. That answers the question.
Yeah. Okay. Thank you.
I said I'm not a consensus expert. It's like something that really a tiny amount of people really well understand.
Thanks.
Questions or things that you're interested in?
Do the others have questions to Kevin or to the blockchain topics? No, no questions. So, was everything clear? Was Kura?
I have a quick question.
Yeah.
In your display on this slide here, why no, can you go back to the previous? Yep. Why do all the arrows from the other two blocks all go to that one block? Shouldn't it be the other way around, or what's going on there?
That's a great question. That's indeed something I missed in my explanation. Um, if you create such a block, right, you have your hash, and then you create a new block, you have a new set of transactions, and that's why it's called blockchain. You also include the old hash. into your new hash. So that forces you, like that creates the integrity on the blockchain, that you can't change old transactions and you can't change the new ones. And the further you go back, the more difficult it gets to manipulate the blockchain state. That explains why the errors basically go back, because they grab the hash from the old block as well and include it in the new one too. So it's a hash in a hash in a hash in a hash at some point. And for some reason are able to go one back, you have to go another one back, another one back, another one back, and that's very expensive from a computational perspective. Does that answer the question?
Yes, thank you.
Perfect. Does someone else have one question? Because if we have Kevin here, he can still answer questions. If not, I would say thank you, Kevin, for your great explanation as usual and for your time to make it. And yeah, thanks a lot for diving deeper in the technical background of blockchain, how everything works. Very interesting. Yeah.
For the invite. It was a pleasure. I hope it was helpful.
Yeah. Thank you very much.